Hello guys, welcome back to another episode of post-processing series in which we want to talk about particle tracking. So what is particle tracking? Particle tracking is very similar to stream traces, but the thing is, instead of tracking the behavior of the fluid or any field of desire, we track it with particles. So we indeed put particles in the beginning of, for example, in the inlet of the domain, and then we want to see what happens to those particles. This is indeed the video, the animation that we seek to create in this episode, in this video, which is indeed a velocity field in a bent pipe, but also some particles that are moving around because of this field, and they have also some some sort of temporary streamline behind them that shows the path that they have taken. This is indeed pretty cool, very nice representation of fluid domains, which you can employ to visualize your simulations, but also sometimes get some quantities out of that. For example, how long does it take for a particle, for a specific particle in a domain, in a specific region of the domain to reach, for example, another specific point, and this kind of data. But at this video, I want to discuss only how to create this representation. So the file for this particle tracking are located in this particle files, which is also another parallel simulation. So I have a PVD file here that collects and group all the files together, but each file is indeed, each time step consists of 6 submeshes or partition mesh. So let's start ParaView, and I open the particle files. So I go to this one and the particle files, and I open the PVD file. And I click apply. So this is indeed my domain. These are indeed my partition mesh. I have nothing to do with this. But in previous videos for this type of partition mesh, I told you that I will demonstrate how to remove these lines, because this is indeed just for the type of simulation that I create, the type of mesh partitioning. These are indeed the mesh that they have overlap on this region. So you can see that the mesh is just normal mesh, but some of the elements and these zones are shared between different domains. So if I want to remove these boundaries, that is pretty simple for me. What I need to do is indeed I need to, for example, you see that they have specific labels, that is I think 0, so I can apply a clip filter for the label, and I clip the filter 0, but the inverse. So this is indeed how we can get rid of those lines for ghosts. Yeah, they are sometimes called ghost nodes for those shared elements in ParaView. But anyway, now I have this, and I want to quickly create the vector field out of this for the velocity. So as I showed you in previous videos, you multiply by I hat and v, the vertical component multiplied by j hat, and then click apply, and I have the velocity, the new variable here. So you can see that this is indeed how this velocity field looks like. So how to add those particles to this? The thing is, in order to do that, we can use the filter of we have different particle filters in ParaView. particle path and particle tracer. I will use particle tracer, but particle tracer needs two input sources. So first one is indeed the main input, which is this calculator, because it contains the velocity variable, the field variable, as well as the seed source. Seed source is very similar to what you saw for stream traces for this filter, but in this case we have to create a source ourselves. So I insert one, for example here, line. You can create a line source, or you can have point source. In this case, I want to have a line source. So this is something like this. Again, you know how to deal with this point selection and point specification things in ParaView. So I created. This is indeed the beginning of the particles, so this is the initialization of the particles. So it's always better to put them inside the domain, but just a bit inside, not for example in the middle, but not on the boundary of the inlet, but a bit inside. So in order to do that, I will select I think 1/10 for the X. Yeah, that's it. And for the Y also 1/10, and for the Z it is 0, and the length of the input I think is 2, so it should be something like this. This is 1/10. And then again for the Z also 0, so this is indeed a line that I want to use. And yeah, this is indeed what I wanted to have for the line. And now this is ready for the insertion of the particle tracer. For the particle traces, I want one input, which is indeed this one, and also seed source, which is this line source. When I click apply, now I have two objects for each of these two, but so it says that this is indeed is taken for the particle tracer one and this one as well, but the main object is indeed this one. There is one important thing here, that is force injection every n step. 0 means that we want to insert the point at each time step, because this is as I showed you, this is an animation, a time series, time sequences. And then for example, if I insert 10, I mean that I want to have the points at each 10 steps. So points are inserted every 10 steps. So I have, before that I will go for zeros. So you see that I have some points here. If I go start the animation, oh, sorry, I think insert every n step. Yeah, 0 means just insert once. So I have to save 1 if I want to have, for example, more points appear. So yeah, this is indeed how it looks like. And you know that you can, even for this particle tracker, you can use whatever variable that you want to select. But indeed, that's the way that it works. So I also start to visualize the field, and these are indeed the variables, the points. And yeah, so you can see that the points are inserted. They are very small at this point, at this moment. In order to make them a bit bigger, I can use maybe glyph. Yeah, why not? We can use the glyph filter, and let's see if it works. Applied glyph filter to particles. It should work. I will say that sphere of this, and then click apply, and then see what happens. Nothing happened. Maybe they are very small at this moment, but yeah, this is indeed it should work. Scale variable, no scaling. Apply. Yeah, the problem was indeed with the scaling. So you can see that now they are very big. I can say, for example, the scale like this, and then bring back the fluid velocity, the velocity field, and then it becomes something like this. So you can see indeed that's how it works. But then how to insert those traces just to show the path that they are taking is indeed an issue for us. We want to add that. But also, before going to that, I want to say something as a minor point. In this case, you can see that indeed the animations are inserted. These points are inserted, for example, every for example 10 steps. Let's do that. Let's apply it, for example, I think every 10 step or so. So the animation would be like this. So you can see that the particles are inserted like this. But in addition to this, you can see that this animation is much smoother for the particles. And the reason for that, the thing is, indeed, I have applied another filter before going to this particle tracking. It makes it less scientifically correct, which I mean that this is not scientifically correct, because you can see that the velocity field is evolving much slower than the particles. So in order to use that, I should have more steps written as the output in my simulation. But this is indeed one demonstration. So having faster particles and a slower velocity field. But as I said, this is not scientifically correct. But if you want to do that, if you want to create such animation, you should apply one filter before this output, before calculating the velocity field. And that filter is indeed temporal interpolation. So temporal interpolation plays a role in filling the gap between time sequences. So when you have a time sequence that is, for example, where B, I mean the time step, and you want to fill the between data steps that you haven't written in your simulation, this temporal interpolator works as a correct tool to fill the gap for you. But sometimes, for example, for the animation that I showed you, this creates some unscientific stuff if you don't pay attention to the scales and also to the time shifts and this kind of stuff. So at this moment, I don't apply this temporal interpolator to the pipeline browser as a filter to the main source, but just pay attention that you can create this if you like, if you want to create. So this is indeed can be a practice for you to create a smoother animation out of this. So I just say that when you create this, when you follow this, the instruction that I'm following here, you will see that the animation will not be exactly like that, and that's indeed the reason. Another difference, as you can see, obviously, is a number of points here. That is nothing by changing the resolution of the line, I think. Yeah, the resolution of the line. So you cannot find it in the particle tracer. That's the resolution of the source. So I can say that I want 10 points as the resolution, and yeah, that's it. So 10 points, and they are just going around like this. But how to insert those streamlines, temporary streamlines, is another filter. So I remove this glyph. I will insert it later. The filter is indeed, I think, yeah, temporal particles to pass line. A very cool filter that allows us to have those kind of temporary streamlines. So as you can see now, I have a different hierarchy of filters and sources here. When I apply this new filter to my data, I can see that it divides and it creates, indeed, generates two output. As in the pipeline browser, one is the path line, which were those path tracks, let's say, and then particles. So it also gives me the particles here. I click apply, and then let's see what happens. Oops. So you can see that I have only one path. It's being plotted here. So the reason is the mask points here. So mask points means, for example, ignore 100 points and then have one of these traces. So for example, if I put 5 here and I had 10 points as the resolution of my line, you see that I have 3 lines here, because indeed it says that ignore 5 points and insert a line and then another 5. So if I say 1, then it means that please create that for every point that I have in the data. So it will be something like this. And the reason that it is a bit distorting is because of this maximum track length. I can change it a bit. I can say that I want to be 15. And also for ID channel, I can say go to the particle ID in order to not mix this stuff together. But yeah, and also maybe I should, because there are no, you see that the new particles are inserted very fast. I should change that inject particles, for example, every 30 steps. Then I click apply, and I see that yeah, this is indeed what I wanted to have. So just remember, for the path lines, still again you have to choose which quantity you want to present. So I say that I want to have magnitude of the velocity, because it tells me at each point, like for example here, that indeed what is the previous velocity profile at this point. So you can choose what you want to have as this stream, at this path lines for the variable that you select. So this is crucial indeed, and it allows you to implement your ideas for a wide variety of different visualizations. That's indeed the pretty and the beauty of applying multiple sources and filters. You can visualize a variety of different quantities at the same time. So now you know what you should do. These are indeed sources. I can apply a glyph to these particles, which is indeed sphere, no orientation, of course, because and no scaling. Orientation is not important in this case, because I selected sphere, and then I click apply. I think they will become very big, and then I select something like this. I think it's good, not bad. And then you can select, for example, change the color, change a solid color to another color, like something like this. So you see, you have control on each aspect of this visualization of this hierarchy. And then for the path lines, I can have, because when it goes on, these are still very thin. I want to make them a bit thicker. So I should apply again another filter with this path line selected. I insert a tube filter to that, and very similar to the previous, for the way that I made those stream traces thicker, I apply some sort of, these kind of tube filters to that. So for this one might work also. No. So I should say that a no scalar. But yeah, this is indeed not important at this moment. But now, so because it doesn't have any rotation, but it's important that, again, which quantity you want to display there. So for me, this is the velocity magnitude. And then by having this, you can see that yeah, this is indeed how that the kind of tracing for the particle tracing works indeed. But yeah, I repeat it again, that the difference between this animation that you see here with the animation that I put here is indeed the lack of temporal interpolation that you can apply before creating this calculator, before creating this velocity field. So make sure to reproduce this one, and also if you have enough time, try to apply this interpolator, temporal interpolator filter to this output before going to the calculator and see if you can have smoother animations out of it. So enjoy and try to visualize your ideas through a different set of filters and sources. So see you later. Bye.